All right, picture this. You're sitting in the exam hall, the clock is ticking, your paper is open, and you're staring down a high-stakes, multi-mark question on 12.2 energy yield, specifically aerobic versus anaerobic respiration. Look, this topic appears in literally every single Cambridge A-Level Biology 9700 examination series. If you get it wrong, you're not just dropping a single mark. You are seriously risking a slide down an entire grade boundary. So take a look at this calculation. I'm going to give you 3 seconds. Can you spot the grade-dropping error before I point it out? 3, 2, 1. Okay, so a student calculates the net ATP yield, they write down the exact correct numerical figure, they completely nail the difference between the aerobic and anaerobic pathways, and they still lose half the marks. No way, right? Keep that specific error in the back of your mind because we are going to expose exactly what that mistake is and why it happens so often in just a few minutes. Let's get into it. Because here is the brutal truth. Ordinary revision, it just fails for 12.2 energy yield. If you're sitting there just rote memorizing the textbook definitions of glycolysis and the Krebs cycle, you're walking into a massive trap. Academic benchmarks for this syllabus don't just want facts, they demand logical, structured reasoning. The examiners aren't just testing your memory of whether aerobic respiration yields 38 ATP and anaerobic yields 2. No, they are actively testing your ability to evaluate evidence, calculate statistics, and draw actual logical conclusions based on that data. So, what does this all mean for us? How do we absolutely guarantee those marks? Well, we use an elite examiner-approved framework designed specifically to rescue lost marks in complex biological calculations.
Which brings us to Section 1, the method mark strategy.
This right here is a real game changer. The secret lies in a rigid 4-step sequence. Number 1, the concept. 2, evidence or data. 3, scientific reasoning. And 4, examiner wording. When you actually construct your answers using this exact sequence, you literally force the examiners to award you crucial process marks, what we call method marks, even if your final calculation somehow gets a bit messed up. You identify the concept, apply the principle, show clear working, and use the exact scientific phrasing they want. So if you're arguing that 38 ATP versus 2 ATP yield, you state the concept, drop the data, reason through the role of oxygen as the final electron acceptor, and use the right terminology. In a minute, I'll show you a hidden examiner clue that completely flips how you should answer these. But first, let's see how this 4-step strategy applies to evaluating data. Let's move on to Section 2, Analyzing Data and Evidence. Okay, so data interpretation skills here are absolutely critical. You have to know which statistical tool to pull from your toolkit because the syllabus is incredibly unforgiving about this. Say you're asked to analyze respiration rate data. Looking at this breakdown, you've got to use the t-test for comparing means, like say between 2 different temperatures affecting aerobic respiration. Use the chi-square test when you're dealing with categorical data, and use correlation tests for relationships between variables. Pick the wrong test. Your entire evidence-based conclusion just completely falls apart. But what if you're hit with a practical work question? Well, the procedural framework for practicals in 12.2 is just as rigid. It's like a recipe you have to follow sequentially to secure maximum observation marks. First, select the appropriate apparatus. Second, follow the instructions in order. Third, make accurate observations and record your data clearly. Fourth, spot the anomalies, the weird data points. And finally, draw those evidence-based conclusions. If you miss even one step, you break the entire chain of logic the examiner is tracking. The key is applying this in real time. So let's actually put this framework to the test. Section 3, Flawed versus Perfect Answers. Let's play examiner for a second and look at a real-world scenario. I want you to pause and predict here. A student writes a beautifully detailed paragraph describing the high energy yield of aerobic respiration. Great. Then they write a second, separate paragraph describing the low energy yield of anaerobic respiration. They mention all the correct facts. Everything is factually true. Yet they score a low band. Why? Where is the fatal flaw in this student's comparative analysis? Here is the secret they don't explicitly tell you. Higher order assessment objectives demand actual, literal evaluation. Comparative analysis means identifying similarities and differences, using comparative connectives, supporting each point with evidence, and drawing a conclusion. That flawed student, they just listed facts separately. They gave a descriptive answer when the framework strictly demanded an evaluation one. Look at this side-by-side correction. It's night and day. On the left, we have the flawed generic answer. Zero context, just listing facts about ATP independently. But on the right, that's your improved top-band answer. It is context-specific. It uses comparative connectives like whereas or in contrast. It directly links the data from the graph to the concept of energy yield, and it wraps up with a justified conclusion. Honestly, this right here is the difference between a C grade and an A star. It is all in the structure. Now that we've fixed the structure, we need to talk about the hidden traps. We actually went straight to the source, digging through Cambridge Principal Examiner reports to find exactly where candidates are consistently bleeding marks. Section 4. Top 3 Examiner Warnings. Let's count down the top 3 most dangerous exam traps. Number 1. Missing units in calculations. Yep, this was the grade-dropping error from the very beginning of our explainer. You do all the hard math, you calculate the perfect ATP number, but you forget to write down the specific units for energy yield, like kilojoules per mole. You just gave away easy marks. Number 2, forgetting to check terminology. And number 3, the absolute biggest killer of them all, generic answers that aren't specific to the context given in the question. Seriously, don't just take my word for it. The Principal Examiner report explicitly warns the classic mistake is providing generic answers. Always link every point to the given scenario. Furthermore, the reports point out that candidates who reference cross-topic connections score significantly higher. Your answers cannot exist in a vacuum. You have got to connect the theoretical architecture of energy yield to the exact scenario sitting right there on your paper. Okay, a quick hack for you to make sure you don't blank on terminology when the exam pressure hits. Create your own mnemonic using the first letters of key terms. For example, to remember the order of the aerobic stages, glycolysis, link reaction, Krebs cycle, and oxidative phosphorylation, just think, great learners keep organized. Having a fast, reliable mental trigger like that frees up your cognitive load, which means you can focus on the higher-order tasks like statistical analysis and evidence-based reasoning instead of panicking over vocabulary. Okay, so you now have the structural framework to secure those process marks. But there is a massive, unresolved problem we haven't even touched yet. Which brings us to Section 5, the diagnostic cliffhanger. Think about it. You can know the biology perfectly. You can have this entire method memorized flawlessly. But what happens if you misinterpret the specific command words on the paper? If the examiner says evaluate and you only describe, your brilliant, perfectly contextualized biology knowledge is literally useless to them. You score 0 for that section. Are command words secretly capping your grade without you even realizing it? This right here is the hidden cause behind so many lost grades, and leaving it to chance is just not an option. You absolutely have to understand how command words dictate the descriptive, analytical, and evaluative levels of the mark scheme, and that is exactly what we are breaking down in our mandatory next explainer, Biology 9700 command words that decide the mark band. You have the biological framework. Now you need the examiner's linguistic key. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Ask yourself, is your current revision strategy building your grade, or is it secretly tearing it down? Click the explainer on your screen right now to master those command words, and I'll see you over there.